Imagine a place on Earth more alien than anything on Mars or the Moon. A realm so deep that if you drop Mount Everest into it, the peak would still be swallowed by more than a mile of ocean. This isn't science fiction, it's the Mariana Trench, a hidden world in the western Pacific Ocean that stretches for over 1,500 miles. It plunges down to nearly 36,000 feet, a depth that pushes the very limits of what we know about life and Earth itself. This trench isn't just the deepest part of the ocean, it's one of the most extreme environments anywhere on the planet. Total darkness, near freezing temperatures, and pressures that could crush a submarine surround everything that dares to live there. Yet life does exist in this brutal zone. In fact, the more we explore it, the more we realize just how little we truly understand about Earth's last great frontier. The Mariana Trench is not just a geological scar, it's a gateway to a world of strange creatures, unexplained sounds, bizarre ecosystems, and deep scientific mystery. And we're only beginning to uncover its secrets. Let's dive deeper and start with what life looks like in this crushing, otherworldly place. At depths beyond 20,000 feet, we enter what is known as the Hadal zone, named after Hades, the Greek god of the underworld. This region, which includes the Mariana Trench, begins around 6,000 meters and extends to the ocean's deepest point. The trench alone accounts for nearly half of the ocean's depth, yet it covers only about 1 to 2% of the seafloor. Despite its limited area, it holds some of the most extreme conditions found anywhere on Earth. Down here, pressure reaches over 15,700 pounds per square inch. That is enough force to crush most submarines and distort the very proteins that life depends on. Temperatures hover just above freezing, and there is no natural light, no sunlight, no photosynthesis, and no traditional food chain. Yet life not only exists, it thrives. Microorganisms have adapted by using special molecules called piezolytes to keep their cells from collapsing under pressure. Enzymes in these organisms are uniquely structured to function in the cold and crushing dark. Some of the deepest studies, like those from the Mariana Trench Environment and Ecology Research Project, have shown us a complex microbial world that challenges our understanding of biology. These life forms are not only surviving, they are actively forming ecosystems. By feeding on chemical reactions, falling organic matter, or even minerals from the seafloor, they build a web of life completely detached from sunlight. And this is only the beginning. In the next part, we'll meet the strange, almost alien creatures that have evolved in these depths. Creatures that look more like science fiction than anything familiar. The deeper we explore the Mariana Trench, the more surreal the life forms become. These creatures are not science fiction, they are real animals perfectly adapted to survive where sunlight has never reached, where pressure would crush nearly anything from the surface. Evolution in the trench has taken some truly strange paths, producing organisms that defy our expectations of what life can look like. One of the most extraordinary examples is the Xenophyophora. Despite being a single-celled organism, it can grow up to 4 inches long, about the size of a mango. These giant, fragile cells drift along the seafloor at depths beyond 10,600 meters. Scientists still do not fully understand how they maintain their delicate structure under such intense pressure, but they play an important role in deep-sea ecosystems by filtering and trapping organic material. Another standout is the Hadal snailfish, Pseudoleparus suaire, found as deep as 8,000 meters. Its translucent, gelatinous body has no swim bladder and no hard bones, which would collapse under pressure. Instead, it moves gracefully in groups and feeds on tiny crustaceans that drift through the water. These ghostly fish are now recognized as the deepest living fish ever discovered. Smaller but no less impressive are amphipods like Hirondellea gigas, which grow unusually large in the trench. These scavengers thrive in the extreme cold, cleaning up organic debris that falls from above. Meanwhile, predators like the dragonfish prowl the depths with glowing lures and nearly invisible teeth. The dragonfish uses bioluminescence to hunt in total darkness, a biological adaptation that helps it survive in an environment where energy is scarce and hunting opportunities are rare. Then there is the Dumbo octopus, a soft-bodied cephalopod with ear-like fins that help it navigate the abyss. It holds the record as the deepest living octopus ever found, discovered near hydrothermal vents and isolated undersea ridges. Instead of relying on chance encounters to mate, it stores sperm for later use. an evolutionary workaround for a world where partners may be few and far between. The diversity of life here is stunning, but scientists estimate that we have only documented about 10% of the species that actually live in the deep ocean. Every new expedition into the trench brings discoveries that expand our definition of life on Earth. But it's not just what we can see that fascinates researchers. The trench also holds mysteries we can hear. In the next part, we'll explore the eerie and unexplained sounds that echo through the darkness of the deep. While the Mariana Trench is cloaked in perpetual darkness, it is far from silent. In fact, the deep sea is filled with strange, sometimes unexplainable sounds. These echoes travel vast distances through water, bouncing off canyon walls and drifting through miles of empty space. Some are biological, others are geological, and a few remain unsolved mysteries that hint at unknown forces or life forms. One of the most famous unexplained sounds recorded in the Pacific was the bloop, picked up in the summer of 1997. Using hydrophones originally designed to monitor submarines during the Cold War, researchers detected an ultra-low frequency sound that was so loud it was heard over 3,000 miles apart. Its profile resembled that of an animal call, which led to wild speculation. Could it have come from an enormous creature living undetected in the trench? Later studies suggested it may have come from icequake activity, like icebergs cracking and moving. But the original recording still captures the imagination because the exact source has never been conclusively proven. In 2014, researchers deployed autonomous underwater gliders near the Mariana Trench to monitor sound. That's when they caught another strange audio event, later dubbed the Western Pacific Biotwang. This sound lasted roughly 2.5 to 3.5 seconds and included multiple layers. It began with a low-frequency moan, then rapidly shifted into a high-pitched metallic twang. The sound was so odd and complex that some described it as resembling science fiction space engines. For several years, its origins stumped oceanographers. It wasn't until 2018 that researchers finally connected the biotwang to a specific animal, the bride's whale. By analyzing over 200,000 hours of acoustic data and matching the sound patterns with known whale migrations, scientists confirmed that male bride's whales were responsible for the call. They believe it may be part of a mating display, though the exact meaning and function of the sound are still under study. These deep-sea sounds show how much remains unknown in the trench. Every strange frequency recorded could be a clue to geological activity, new species, or behavior we do not yet understand. And in the Mariana Trench, sound is often the first, and sometimes only, evidence we have of what is happening in the blackness below. But just as sound tells part of the story, the trench's formation and behavior reveal even more about how our planet works, which we'll explore next. The Mariana Trench is not just a static abyss, it is a dynamic, ever-changing scar on the Earth's crust, shaped by immense geological forces that have been grinding away for tens of millions of years. Its existence is the result of one of the planet's most powerful natural mechanisms, subduction. This is where one tectonic plate is slowly forced beneath another, a process that continues to mold the planet's surface. The trench marks the boundary where the enormous Pacific plate is diving underneath the smaller Mariana plate. This collision zone is one of the most geologically active places on Earth. As the plates interact, massive amounts of energy build up along the fault lines. That energy is occasionally released as earthquakes, some of which are strong enough to reshape the seafloor and trigger tsunamis. While most of these earthquakes go unnoticed on the surface, they play a vital role in maintaining the planet's internal balance. The trench itself stretches for over 1,500 miles, forming part of what's called the Izu-Bonin-Mariana Arc System. This arc system is home to numerous seamounts, ridges, and underwater volcanoes. These features are not just geological curiosities, they are crucial for understanding how ocean crust is recycled back into the Earth's mantle. As the Pacific plate descends, it melts and creates magma that can eventually rise and form volcanic islands like those found nearby in the Mariana Islands chain. One of the most intriguing discoveries in recent years is the presence of deep-sea mud volcanoes and serpentinized rocks in the trench zone. These rocks form under extreme pressure and release hydrogen and methane as they react with seawater. That release of gases fuels microbial life, offering a chemical-based food chain that operates independently from sunlight. This is a key piece in understanding how life might arise on other planets or moons where similar extreme conditions could exist. Hydrothermal vents have also been detected in nearby regions, spewing superheated, mineral-rich water from beneath the crust. These vents are like underwater geysers, surrounded by unique ecosystems of tube worms, clams, and bacteria that thrive on the chemical soup they provide. Though not yet fully mapped in the deepest parts of the trench itself, these systems are believed to exist along its flanks, contributing to its complex geological activity. Together, these forces make the Mariana Trench a vital window into Earth's inner workings. The pressures, temperatures, and tectonic motion taking place here are unlike anywhere else on the planet. But while Earth's forces shape the trench from below, it's the human desire to explore that pushes us to understand what lies within. And that's what we'll explore next. Venturing into the Mariana Trench has long captured human imagination, but turning that curiosity into actual exploration is no small feat. The conditions at these depths push technology, engineering, and human endurance to their limits. Pressure down there can exceed 1,000 times the atmospheric pressure at sea level, making every dive a battle against forces that would instantly crush ordinary equipment. The first manned expedition to reach the bottom was in 1960 when the bathyscaphe Trieste, piloted by Jacques Piccard and Don Walsh, descended into the Challenger Deep. Their trip was historic but brief, and the technology at the time allowed only limited scientific observations. Since then, progress has been slow but steady, with remote-operated vehicles and unmanned probes increasingly used to gather data without risking human life. In 2012, filmmaker and explorer James Cameron made a solo dive in the deep-sea Challenger submersible. His mission combined cutting-edge materials and new design techniques to withstand the immense pressure. Cameron's dive lasted nearly 3 hours, during which he captured high-definition footage that gave scientists an unprecedented view of the trench's environment. More recently, Victor Vescovo's expeditions with the Limiting Factor submersible have set new records for depth and repeat dives. These missions have focused on detailed mapping, collecting geological samples, and documenting deep-sea creatures in their natural habitat. Advances in materials like titanium and specially designed syntactic foams help these vessels survive pressures over 1,000 atmospheres. Lighting the trench is another challenge. Sunlight does not reach these depths, so explorers rely on powerful external lights. However, these lights can disturb fragile animals or alter natural behaviors, so scientists must balance the need for observation with the goal of minimizing impact. Communication during deep dives is also limited. Radio waves do not travel far underwater, so most data and videos are stored on board and retrieved after surfacing. This delay means explorers often have to make decisions without real-time input, adding to the complexity of missions. Despite these obstacles, exploration continues because the Mariana Trench offers unique scientific opportunities. It helps researchers understand life's limits, plate tectonics, and Earth's geology. Plus, it satisfies a basic human urge to explore the unknown. Future expeditions aim to establish long-term monitoring stations and deepen our knowledge of microbial life and geology in this remote realm. This spirit of discovery is what keeps pushing us to the very edge of the world's deepest frontier. The Mariana Trench's mysterious nature has made it fertile ground for myths and imaginative stories. Its vast darkness and inaccessibility invite speculation where scientific knowledge leaves gaps. Over the years, many legends and theories have taken root, blending human creativity with the unknown. One popular idea is that massive undiscovered creatures lurk deep within the trench. Tales speak of kaiju-sized beasts or enormous sea monsters that have evaded detection by modern technology, while science has revealed some unusually large or strange creatures like giant xenophyophories and deep-dwelling snailfish. There is no credible evidence of gigantic monsters lurking in the abyss. Another common theory involves secret government operations. Some speculate that hidden military bases or research labs exist within the trench's remote canyons, possibly for testing advanced technology or studying unexplained phenomena such as unidentified submerged objects. The extreme difficulty in monitoring the area makes such stories plausible to some, but no verified information supports these claims. Stories about lost civilizations also circulate. Enthusiasts propose that remnants of ancient cultures, perhaps like the mythical Atlantis, could be buried beneath the trench's crushing depths. Proponents often point to unclear sonar images or unusual underwater formations as hints. However, geology shows that the trench is a subduction zone where oceanic crust is drawn down and recycled into Earth's mantle, making the preservation of such structures extremely unlikely. Even so, these ideas highlight how the Mariana Trench captures human fascination beyond pure science. The blend of reality and imagination underscores our enduring desire to explain the unknown, and the trench remains a symbol of both mystery and discovery. As exploration continues, separating fact from fiction will remain an important part of understanding this extraordinary place. As we wrap up our journey into the Mariana Trench, it's clear this remote part of our planet still holds countless secrets waiting to be uncovered. Despite decades of exploration and the incredible technology developed to brave its crushing depths, more than 80% of the ocean remains unmapped and largely unexplored. The trench itself represents one of the final frontiers on Earth, a place where science meets mystery in a profound way. Recent discoveries continue to surprise us. In early 2025, researchers reported dozens of new species in the trench, ranging from glowing deep-sea fish to giant microbes previously unknown to science. Some estimates suggest nearly 90% of microbial genomes found there are completely new, highlighting just how little we truly know about life in the deep. Studying this environment not only expands our understanding of biology and geology, but also teaches us about the limits of life on Earth. The extreme pressure, cold temperatures, and total darkness push the boundaries of what living things can endure. Each expedition brings fresh insights into Earth's dynamic inner workings and the resilience of life in its most unlikely places. Looking ahead, future missions will likely focus on detailed mapping, long-term monitoring, and deeper investigations into the trench's unique ecosystems. These efforts will require continued advances in technology and global cooperation. The Mariana Trench remains a symbol of human curiosity and the enduring allure of the unknown. It reminds us that even in the 21st century, our own planet holds mysteries as vast and profound as any found in space. The deep sea's darkest depths invite us to keep exploring, questioning, and learning, because the story of the Mariana Trench is far from over. The deep ocean is one of the most mysterious and extreme places on Earth. Starting at depths of over 1,000 meters, sunlight completely disappears, leaving a world of total darkness and crushing pressure. Temperatures hover just above freezing, and the environment is so harsh that only the hardiest creatures survive. Among these creatures is the deep-sea anglerfish, a bizarre and haunting predator that has evolved some of the strangest adaptations in the animal kingdom. Its unsettling appearance and behaviors make it far more terrifying than it might seem at first glance. Over the next several minutes, we'll dive into the unsettling truths about this creature and uncover why it truly deserves its fearsome reputation. The deep-sea anglerfish has a look that many would call nightmarish. Its massive mouth is filled with long, needle-sharp teeth that point inward like spears. Designed to trap any unlucky prey that gets too close, this mouth can open incredibly wide, making it seem as though the anglerfish could swallow anything that fits into the dark ocean around it. One of its most haunting features is the bioluminescent lure that dangles just above its head. This glowing fishing rod is actually a modified spine tipped with bacteria that produce light, allowing the anglerfish to attract curious prey in the pitch-black depths where sunlight never reaches. The lure's eerie glow is not just for show, it's a deadly trap. In the crushing darkness of the deep sea, where food is scarce and vision is nearly useless, this light acts as a beacon to unsuspecting fish and other creatures. They swim toward the glow, thinking it might be food or a safe hiding spot, only to swim straight into the anglerfish's open jaws. This hunting strategy is incredibly effective because the light can be turned on and off at will, giving the anglerfish control over when to attract and when to ambush. This deceptive tactic is especially important because the deep ocean offers very few opportunities to find a meal. Many creatures rely on bioluminescence to survive, but the anglerfish uses it in one of the most sinister ways imaginable. Unlike predators that chase their prey, the anglerfish stays still, conserving precious energy in an environment where food might not appear for days or even weeks. The glowing lure is the perfect tool for this patient predator, tricking prey into coming close enough to be swallowed whole. This combination of terrifying appearance and clever adaptation makes the deep-sea anglerfish one of the ocean's most fearsome hunters. The deep-sea anglerfish's jaw is a masterpiece of evolutionary horror and efficiency. Unlike most fish, its jaw is not rigidly fixed. Instead, it is hinged in such a way that it can open extremely wide, wide enough to swallow prey nearly twice its own size. This incredible flexibility is crucial for survival in the deep ocean, where meals are rare and opportunities to feed must be seized no matter how large or small the prey may be. Its teeth, long and needle-thin, curve inward like traps, ensuring that once something is caught, escape is almost impossible. Inside, the anglerfish's stomach is just as remarkable. It can stretch and expand dramatically, allowing it to accommodate prey much larger than what a typical fish of its size could handle. This means the anglerfish doesn't need to worry about how big its next meal is. If it can catch it, it can swallow it whole and digest it slowly over time. In the deep sea, where food can be scarce for weeks or even months, this ability to gorge and store energy is a key survival strategy. When hunting, the anglerfish relies on a sudden and lightning-fast lunge to capture prey. Without much light to guide it, this predator depends heavily on detecting vibrations and movements in the water using its highly sensitive lateral line system. It can sense the slightest ripple caused by nearby creatures. The attack is swift and precise, a surprise strike in total darkness. Because prey is so infrequent, the anglerfish cannot afford to miss its chance, so its instincts are finely tuned to make that first snap count. What makes this even more chilling is that the anglerfish does all of this in an environment of crushing pressure and near freezing temperatures. At depths of over 1,000 meters, the water pressure is more than 100 times that at sea level. Its jaw, muscles, and body have evolved to function perfectly under these conditions, which would crush most other animals instantly. The anglerfish is a living example of extreme adaptation, a predator shaped by desperation and darkness, designed to take advantage of whatever opportunity comes its way in the vast abyss. This combination of an unhinging jaw, expandable stomach, and rapid attack method makes the deep-sea anglerfish a terrifying hunter, perfectly suited for one of the most unforgiving environments on Earth. It is a creature built to survive in a world where food is a rare prize, and every meal could be its last chance to eat. The mating behavior of the deep-sea anglerfish is one of the strangest and most unsettling reproductive strategies found in the animal kingdom. Unlike most fish, where males and females meet, mate, and then go their separate ways, anglerfish males take a far more extreme approach, known as sexual parasitism. The male anglerfish is tiny compared to the female, often just a few centimeters long, while the female can be up to 10 times larger. This enormous size difference is a key part of their unique mating system. When a male anglerfish encounters a female, he bites into her skin with his sharp teeth and permanently attaches himself to her body. Over time, the male's tissues and circulatory systems fuse with those of the female. His organs slowly degenerate, except for his testes, which remain functional. This fusion turns the male into a living sperm bank, supplying the female with sperm whenever she is ready to fertilize her eggs. It's a chilling form of dependency, where the male literally becomes part of the female's body, losing his independence entirely. A female anglerfish can have multiple males attached to her at once, sometimes up to 6 or more. Each male remains small and parasitic, unable to survive on his own without the female's body providing nutrients. This system ensures that when the female is ready to spawn, sperm is immediately available, which is crucial in the vast, dark depths of the ocean, where finding a mate could otherwise be nearly impossible. Because encounters between males and females are so rare in this environment, this fusion strategy is an effective evolutionary solution to reproductive challenges. This form of reproduction looks more like something out of a horror story than a typical natural process. It is unlike nearly anything else in the animal world. With a complete loss of autonomy for the male anglerfish, the parasitic males can sometimes be seen as tiny growths attached to the much larger female, a visual reminder of their grim fate. Scientists first described this behavior in detail during the 20th century, with early observations dating back to the 1950s, but only in recent decades has the full biological mechanism been understood. This bizarre and grotesque mating system reflects the extreme pressures of survival in the deep ocean. It is a harsh reminder of how life adapts in unimaginable ways when faced with the challenges of isolation, darkness, and scarcity. Sexual parasitism in the anglerfish is not just a strange quirk. It is a vital adaptation that allows the species to continue surviving in one of the most inhospitable places on Earth. The deep-sea anglerfish faces a world where light is virtually non-existent, making eyesight less useful than it is for most creatures. In fact, many species of anglerfish have relatively small or reduced eyes, relying instead on other highly specialized sensory systems to navigate and hunt in total darkness. One of the most important adaptations is their lateral line system, a network of sensory organs running along the sides of their bodies that detects vibrations and pressure changes in the water. This lateral line system allows the anglerfish to sense the movement of prey or predators nearby without seeing them. It is incredibly sensitive and can pick up even the slightest disturbance in the water, helping the anglerfish pinpoint the location of its next meal in the pitch-black depths of the ocean. This means that the anglerfish hunts largely by feel and vibration rather than sight, patiently waiting in the darkness for prey to come close to its glowing lure. In addition to the lateral line, the anglerfish's bioluminescent lure plays a crucial role, not just in attracting prey, but also in sensing its immediate surroundings. The light it emits is produced by symbiotic bacteria living inside the lure's specialized organ, a unique example of cooperation between species in such an extreme environment. This soft, eerie glow acts as a beacon in the dark, but also gives the anglerfish subtle feedback about movement around it, almost like a trap that alerts the predator when something is close enough to catch. While the anglerfish has traded much of its eyesight, it has not sacrificed precision. Its nervous system is finely tuned to respond instantly to the faintest ripple or shift in water pressure. When the anglerfish senses the approach of prey, it can strike rapidly, a critical advantage when food is so scarce. The deep ocean is one of the most nutrient-poor places on Earth, and the anglerfish must rely on patience, stealth, and its extraordinary sensory equipment to survive. Evolutionary trade-offs have shaped the anglerfish into a patient ambush predator that doesn't need speed or sharp vision, but depends on a blend of vibration detection, bioluminescence, and instinct. This combination makes it an incredibly efficient hunter in an environment where survival depends on making the most out of every opportunity. In the silent, lightless depths, the anglerfish reigns supreme, a terrifying example of how life can adapt in ways that seem almost alien to us. The deep-sea anglerfish stands as one of the most extraordinary examples of how life can adapt to extreme environments. Its grotesque appearance, from the oversized mouth lined with needle-sharp teeth to the glowing lure that dangles like a deadly beacon, reveals a creature shaped by the harsh realities of the deep ocean. Each of its adaptations, whether it's the jaw that can swallow prey larger than itself, the bizarre mating process where males fuse permanently to females, or the finely tuned sensory systems that operate without reliance on sight, tells a story of survival against incredible odds. Living at depths exceeding 1,000 meters means enduring crushing pressure, near freezing temperatures, and complete darkness. These conditions have driven the anglerfish to evolve in ways that seem almost nightmarish. Its ability to consume virtually anything it encounters is essential because food is scarce in the abyssal zone. This opportunistic feeding strategy, combined with its deceptive bioluminescent lure, makes it an apex predator in a world where prey is hard to find and every meal counts. The reproductive strategy of sexual parasitism is perhaps the most unsettling aspect of the anglerfish's life. Tiny males permanently attaching to much larger females, becoming nothing more than a living sperm source, challenges conventional ideas of animal behavior and reproduction. This extreme adaptation guarantees that when the female is ready to spawn, sperm is always close at hand, increasing the chances of reproductive success in a vast, dark environment where encounters with mates are rare. Beyond its physical and reproductive traits, the anglerfish's sensory abilities highlight an evolutionary marvel. Hunting without relying on eyesight, it uses a sophisticated lateral line system to detect even the faintest movements and vibrations in the water. This allows it to patiently wait in total darkness for prey to approach, then strike with deadly precision. Its bioluminescent lure not only attracts victims, but also provides subtle sensory feedback, enhancing its ability to survive in an environment where light is a luxury. In the end, the deep-sea anglerfish is more terrifying than most people realize, because it embodies the extremes of nature's creativity under pressure. It is a creature sculpted by desperation, darkness, and the relentless need to survive. Its existence reminds us that the ocean's depths hold mysteries far stranger and more unsettling than anything we encounter on the surface. The anglerfish is not just a bizarre oddity, it is a living testament to the power of evolution in one of Earth's most inhospitable realms. If this deep dive into the anglerfish's terrifying world has unsettled or fascinated you, let me know which trait you found the creepiest. Don't forget to subscribe for more explorations of nature's darkest and most mysterious creatures. And join me next time as we uncover more secrets lurking beneath the waves. Over 99% of the deep ocean floor remains unexplored. Just think about that. That is more than twice the surface area of all the continents on Earth combined, cloaked in freezing blackness, under crushing pressure, and largely untouched by human eyes. It is not just unexplored, it is alien. Every time we dive down there, we find something strange, something no one has ever seen before. And more often than not, it changes what we thought we understood about life. We have discovered bacteria that thrive in boiling water near volcanic vents, creatures that glow in total darkness, fish that live miles below the surface, where pressure would crush a human like a soda can. These are not just oddities, they are reminders that Earth still hides secrets as strange as anything imagined in science fiction. But here's the thing. All of those discoveries, they have one thing in common. They make us ask, if we are still finding creatures this strange this often, what else is down there? Could there be life in the deep sea that is not just unusual, but completely unlike anything we have ever seen? Maybe even something that breaks the rules entirely? In this video, we are diving into that question. Could there be life we have never seen at the bottom of the ocean? Life so rare, so strange, or maybe so massive, that it has evaded all of our technology and all of our expectations. We're going to follow the evidence, look at what we know, and let that guide us into what might still be waiting below the deepest, darkest places on our planet. The Mariana Trench, the Hadal Zone, the places deeper than Mount Everest is tall, Earth's true final frontier. Let's begin. The deeper we go into the ocean, the stranger life becomes, and not just a little strange. Radically different from what we see on land or even in shallower parts of the sea. Down in the Hadal Zone, which starts around 6,000 meters and goes as deep as nearly 11,000 meters in places like the Mariana Trench, the pressure is more than 1,000 times what we experience at sea level. There's no sunlight, the temperatures are near freezing, and food is incredibly scarce. Yet somehow life is not only present, it's thriving in ways that continue to stun scientists. What's most surprising isn't just that life exists there, but how diverse it is. In the past 5 years alone, researchers have discovered hundreds of new deep-sea species. In 2023 and early 2024, expeditions off the coast of Chile found over 100 new species of deep-sea animals, including bioluminescent corals, glass sponges, and filter feeders living thousands of meters below the surface. These species are not just variations of known creatures. They're completely new to science, showing us just how little we know about life on Earth. Then there's microbial life. In the Mariana Trench, more than 7,000 unique microbial species have been found, with nearly 90% of them being previously unknown. Some of these microbes survive on chemicals like hydrogen sulfide or methane, things that would be toxic to most surface life. Others show adaptations like ultra-efficient genomes, allowing them to survive with almost no resources. This kind of life doesn't rely on sunlight or even typical carbon sources, making it a possible blueprint for how life could exist elsewhere in the universe. And while microbes get most of the attention, larger animals are just as impressive. The Hadal snailfish, for instance, lives at depths beyond 8,000 meters and has a gelatinous body perfectly suited to survive extreme pressure. Giant amphipods, basically shrimp the size of a small cat, scavenge the seafloor, and the goblin shark, a rarely seen predator, uses electrical signals to detect prey in total darkness. These creatures are not only built for survival, they are the product of millions of years of evolution in isolation. This is not a slow trickle of discoveries either. New research trips are constantly revealing organisms with traits we've never seen before, like the mysterious golden orb found off the Alaskan coast in 2023. Scientists still don't know what it is. It might be an egg, or maybe it's an entirely new species. The point is, even with all our modern technology, the deep ocean keeps delivering surprises. And so, if life can evolve to this degree in such harsh, isolated conditions, what else could be out there? What are we not seeing because our tools just can't go deep enough, stay down long enough, or recognize something we don't yet understand? If the first few layers of the abyss already defy our expectations, then what lies deeper might go beyond anything we've even imagined. By now, we know the deep sea is more than just home to strange life. It's also a place filled with strange signals. Every so often, our equipment picks up something we can't explain, whispers from the darkness that fuel more questions than answers. One of the most famous examples came in the year 1997. A deep, ultra-low frequency sound, later nicknamed the bloop, was recorded across multiple sensors in the Pacific. For a while, no one had any clue what it was. It was powerful, louder than any known animal, and seemed to come from a biological source. Eventually, NOAA scientists suggested it may have been caused by ice quakes, but not everyone agrees. To this day, many still believe it could have come from something alive. And the bloop is far from the only example. Other unexplained underwater sounds have been recorded over the years. Upsweep, a strange rhythmic hum detected since the late 1980s. Julia, a long moaning noise captured in the year 1999. And the Western Pacific Biotwang, a bizarre series of metallic twanging tones that no one has been able to match to any known geological or animal source. These signals often come from the same deep ocean trenches and mid-ocean ridges we've barely explored. Places where sunlight never reaches and few submersibles have gone. Sure, there are plenty of possible explanations. Some may be whales or geological shifts, but here's the thing. Most of these sounds were picked up across huge distances, sometimes thousands of miles apart, and they don't behave like the vocalizations of whales or the rumbling of tectonic plates. If anything, they suggest the presence of something massive, something capable of producing vibrations on a planetary scale. Which brings us to another mystery. Brief shadows, strange outlines, and odd reflections captured by deep-sea cameras. Scientists studying footage from deep-diving, remotely operated vehicles have reported odd blurs, flashes of movement, and shapes that vanish before they can be analyzed. One famous example comes from a 2013 dive in the Gulf of Mexico, when researchers captured what looked like a massive jellyfish or unknown soft-bodied organism stretching several meters wide, only for it to slip out of frame and never appear again. Another case from 2021 involved a set of flickering lights seen from a submersible at the Mariana Trench. They weren't camera glitches or vehicle reflections. They appeared to move independently in a pattern before disappearing into the dark. Add to that the massive creatures we have confirmed, like the giant phantom jelly with its ribbon-like arms stretching over 30 meters, and the siphonophore found in 2020, a deep-sea predator estimated at 150 feet long, and it becomes harder to dismiss the idea that something even bigger, stranger, and possibly intelligent could be hiding in the deep. We once thought the colossal squid was a sailor's myth, but now we know it's real. And still, we've barely filmed an adult in the wild. If myths can be confirmed with time, how many more are just waiting for the right piece of evidence? With only a small percentage of the ocean floor ever directly seen by human eyes, what we haven't recorded may be even more shocking than what we have. The deep sea isn't just strange, it's actively hiding its truths, and those truths may be far more complex than anything we've encountered on the surface. If the deep sea is one thing, it's a place where nature plays by different rules. Evolution down there doesn't just adapt, it experiments. On the surface, life faces constant disruption from weather, temperature swings, and human activity. But deep below, in the Hadal zones and trench floors, the environment is cold, dark, chemically rich, and astonishingly stable. That isolation, it gives life time to evolve in complete secrecy, far away from the chaos above. We see evidence of this in deep-sea gigantism. Creatures like giant isopods, oversized amphipods, and deep-sea sea spiders are way larger than their shallow water relatives. These aren't flukes, they're adaptations. In the pitch-black, high-pressure world of the ocean floor, bigger bodies help conserve energy, retain heat, and move more efficiently through the dense water. Some researchers even believe extreme pressure slows cellular processes, giving some organisms dramatically longer lifespans and more time to grow, change, and evolve. And then there's endemism, species found only in specific deep-sea locations, such as hydrothermal vents or isolated seamounts. In a 2024 expedition off the coast of Chile, scientists documented more than 100 new species, including deep-sea corals and glass sponges. About half were completely unique to that site. That kind of isolation, it's an evolutionary goldmine. Over millions of years, it could lead to life forms that don't just look different, but function differently, with metabolisms, genetic systems, and survival strategies completely foreign to us. One of the most fascinating new possibilities centers around dark oxygen. In recent years, scientists studying polymetallic nodules on the seafloor noticed what might be electrochemical reactions generating oxygen without sunlight, without photosynthesis. If this turns out to be true, it could mean there are entire ecosystems powered by processes we've never imagined. Not only would that rewrite the rules of biology, but it might even reshape how we think life could evolve elsewhere in the universe. And if these alien processes work for microbes, why not for larger life? What if there are deep sea organisms that rely on energy sources we don't yet understand? What if they breathe compounds we consider toxic or see in wavelengths of light we can't detect? Even now, we're finding microbes whose DNA repair systems are unlike anything seen before. If that level of biological strangeness is hiding in tiny organisms, it's not a stretch to imagine something bigger, much bigger, emerging under the right conditions. All of this pushes us toward one very real, very strange possibility, that the deepest parts of our ocean are home to life that doesn't just challenge what we know, but breaks our definitions entirely. A second branch of biology evolving in parallel with everything we've ever studied, hidden beneath miles of pressure and silence, and maybe, just maybe, the reason we haven't found it yet is because we've barely even looked. We usually imagine intelligence through a human lens, tools, fire, language, maybe even space travel, but what if, deep in the ocean, something has followed a completely different path? In the cold, silent darkness of the Hadal zone, life doesn't evolve with sight or sound the way we know it. Instead, it might lean on other senses, electric fields, chemical signals, vibrations, and water pressure. These are all abilities we've already seen hints of in known species like the goblin shark, the vampire squid, and bioluminescent organisms that flash coded light in total darkness. But those are just glimpses. What if something more complex has emerged, something that we'd never even recognize as intelligent? It wouldn't build cities or send signals into space. It might not even move quickly. It could be ancient, slow-growing, and built to last, not for speed or expansion. Picture a being that spans entire geological formations, biological, but more like a living reef than an animal. Or imagine a colony creature, where intelligence is distributed, not held in one brain, but shared through a vast connected network using deep-sea chemistry instead of language. In 2023, researchers recovered a mysterious golden orb from the deep off the coast of Alaska. At first glance, it looked biological, but no one knew what it was. Even now, scientists still aren't sure. That uncertainty is telling. If we're unable to categorize something as basic as an egg case or sponge at first contact, what does that say about our readiness to recognize truly alien life? What if the strangest discoveries are still ahead and we're just missing them? Some experts argue that if intelligent life had evolved in the deep sea, we would have seen evidence, structures, signals, patterns. But what if deep sea intelligence doesn't want to be seen? What if surviving in complete isolation means staying hidden, or existing in a form that never surfaces, never interacts? After all, we've explored less than 1% of the deep ocean. Even the most advanced submersibles and sensors can't stay down for long. And the ocean is vast, so vast that it's easier to search Mars than the deepest trenches of our own planet. So maybe the question isn't, could life exist in the deep sea that we've never seen? Maybe the real question is, how much have we missed already? In a place where life thrives without light, where evolution rewrites itself in secret, and where even sound can seem alien and unexplained, the possibilities stretch far beyond anything we've imagined. As we push the boundaries of exploration, deploying better cameras, more resilient drones, and smarter sensors, we're not just chasing strange fish or glowing microbes. We're peering into a world that has evolved in total independence from the surface. A world where the rules are different, where life doesn't just survive, it reinvents itself. And maybe, just maybe, the greatest mystery of all is that the ocean hasn't kept its secrets from us. We've just never gone deep enough to see what's waiting.